After a static route, we have what's called another type of routes, which are the dynamic routes. If you have watched the last two videos, or maybe the first video of static route, I have mentioned something called, other than static routes, which is the dynamic routing protocols. Dynamic routing protocols are much simpler in configuration, not like static routes. In a static routing protocol or in static routes, you had to manually configure every single hop just to send, and again every single hop to receive the packet. In dynamic routing protocols, all what you do inside the routers is something called advertisements. You only need to advertise the subnet or the prefix that you want anyone to reach or to know, and that's it. The router, using the dynamic routing protocol, and the metric of the dynamic routing protocol will then automatically or dynamically decide how to forward the packet and how to receive back the reply of the packet, or to make anyone who wants to reach you to be able to do that. Okay, so this is the concept of, or the difference between static routes and dynamic routes. In dynamic routes, something that has been removed from the new CCNA, I'll just mention it in a matter of maybe 1 minute. In dynamic routes, there are two families of routing protocols, which were the distance vector family. Those routing protocols seeks the shortest path to go through, like the RIP, and a specific Cisco only protocol, which is the EIGRP. Now we don't need to know about these in the new CCNA. The other family of routing protocols were the link state, who cares about how is the state of the link or the status of the link that the router will send the packet through. Some of them are like ISIS, you will study for it in any service provider certificate, and the other one that we will talk about is the OSPF. These two are very similar in algorithm, in concept of working, in a lot of characteristics are shared between them, but this is a bit difficult and complicated for an associate engineer to study, so it's removed from the associate certificate. Okay, you will find it in the specialized certificates of other vendors, maybe in the professional also, but not in the associate. But also, you would like, if you're interested previously in the previous CCNA service provider, ISIS was there. Okay, that was annoying actually for me to study. So without further discussion, let's start with the open shortest path first, which is the OSPF. This is the only dynamic routing protocols that you will learn or study in the new CCNA. In this one, it's a dynamic routing protocol, just as I have mentioned previously. Something mandatory that you must study with each routing protocol that you know, which is the administrative distance and the metric of every single routing protocol that you will study. The administrative distance here, this should be a capital A, I'm sorry for this mistake, is 110, and the metric is called here a coast. A coast is also a formula, not also, I haven't talked about the EIGRP yet, okay, but a coast is a formula that I did talk about it in the static route video, but no problem, let's repeat it. A cost is the formula that comes, I believe it was 10 to the power of 8 divided by the bandwidth of the path or of the route that the packet will take. What I mean is that some routing protocols will say, I'm now confused, it's either I send the packet from this way or from this way. But in this upper path, I will have to make only one jump, one hop here and the other one, and that's it. I have reached my destination. But in case I did it from this path, it will be one jump, 2, 3 to reach my destination. So I will take this path, this one, the upper path. OSPF doesn't care about how much routers are in the path. Maybe here 10 routers, maybe here only 1, here are 50 routers, here are only 2 routers. It doesn't care at all. It doesn't care at all about the number of routers in the path. Okay, what it does care about is the bandwidth of the total bandwidth of the path. okay? And actually it's not really the entire one. The smallest bandwidth that occurs during or while using the path. What I mean is that maybe the path from this between these two routers is 10 megabit per second, and between these two is 100. I'm sorry. From here there are three links. This is 1, this is 2, and this is 3. So maybe these are 100, 100, 100. What OSPF sees is that there is a bottleneck in here, because it's correct that this link or this connection between these two routers is 100 megabit, but what's the point of this if I have a bottleneck in here which is 10 megabit per second? While from here, yes, it's correct that it's a longer path, it will take more routers in the way, all of them must route me and process my progress to route me forward and backward, but just check this, it's 100 megabit per second all the way. So it's, of course, whatever happens, or how much or how many delays, or sorry, what's the unit, whatever the delay is in the path, eventually it's in the end it's 100 megabit per second, so I don't care. So this path is much better, okay, because it has a higher bandwidth, and since bandwidth it's divided by the bandwidth, then the bigger the bandwidth is, 100 megabit is, mega is a million, so it's 110 to the power of 6. 100 megabit is a 10 to the power of 6. So differentiating these two powers will result in 10 to the power of 2, which is only the cost of 100. What I mean is that when you have something divided by the bandwidth, this means the bigger the bandwidth, the better, because less cost. Of course, all of us want something less costly, so less costs, okay? This is what's required from OSPF, or from the paths that the OSPF will be confused to choose between them, and less cost. So the metric of the OSPF is called a cost. The lesser, the better. Okay, OSPF was built and designed using the Dijkstra algorithm. I believe this was the name of the engineer or maybe the scientist that built OSPF. And after OSPF was built, it was built to use the shortest path first. This is a common criteria or a common algorithm used between OSPF and ISIS. Both of them use this algorithm, to use the SPF algorithm for the route decision. Okay, so it's correct, it's the shortest path first, but it uses cost in this metric. Okay, so this is another thing. The new things in OSPF that you might not see in every routing protocol are these two. OSPF uses a process ID, and it also uses an area ID. What I mean by this is that imagine you are building a network in the United States of America. You know, the United States has more than 50 states. So if I want to cover all the United States in a single network, okay, all of them connected together, each state is very big and maybe contains 100 maybe to 1,000 router in a single state. Okay, so what will happen if I just hit, if you have seen this command in the previous videos, which is show IP route, and show IP route will show to me the installed routes in the routing table. Okay, what will happen if I just hit this thing is that it will show me there are installed routes of, how much are they? Maybe 50 multiplied by 100 router for each state, 5,000 router. Each one of them maybe has from 10 up to 100 route. So this is impossible to be shown. Okay, so the first type of isolation and categorization for your network is the process ID. The process ID is the OSPF number, unique number that you assign to OSPF in order to isolate your networks or your routers, each one of them in a region, or each one of them maybe in a category. Like you can give a process ID for each state, And thus you know that OSPF process ID 1 is for New York, OSPF process ID 2 is for Los Angeles, OSPF process ID 3 is maybe for whatever other name, okay, of United States. So you will separate each one of them from the other. This is the first thing. So it's for multiple instances. Yes, they can communicate together by using routing between them, but it's very important when you have big network. In small networks, maybe in the networks that we will build in this course, in the entire CCNA course, we can just do OSPF 1, hit enter in the router, and that's it. No need for OSPF 2, 3, 4, or whatever. This is more than enough. Okay, so this is the first thing. The other thing is that if the process ID covers a big region, like maybe, I don't know how to explain it exactly, maybe by using the same example of the states of USA, but maybe each state has its multiple province and territories. Okay, so because it's very big, each state is in the size of a country. So that means a lot of province and territories, and yet still I want to isolate each one of them in a single routing table, or maybe in a specific isolation, just to reduce the overload and the headache on the resources of my routers. So each one of them should know only about the routers that are in its area, and this area belongs to its process ID. So that's enough, because it will communicate locally between them. Okay, because in the end, OSPF is considered to be an interior gateway protocol. This is a protocol to be used inside your network. This is not an internet protocol. Internet protocols, which will face dozens and hundreds of routing protocols and installed routings in its routing table, are called exterior gateway protocols, which until now we have only a single exterior gateway protocol, which is called the border gateway protocol, the BGP. This has been removed, unfortunately, from the new CCNA. You will study in the CCNP, in the core, and in the advanced routing process of the new CCNP enterprise. But this is the only routing protocol that deals with the internet. The IGP, like RIP, OSPF, and ISIS, and also the EIGRP, this is one of them. Also, the static route is different. I'm talking about the dynamic. Like the OSPF, this is meant and designed to be used inside your network. So as long as inside my network, how big can my network be? Maybe at maximum 50 router. I'm sorry. Maybe at maximum a 50 router. So a 50 router is enough to be contained in a single area or in a single process ID. That's all I need. Okay, so again, let's clear the mess. Maybe in my state, it's a big region, but I want to divide it to 5 different provinces or territories. All of them, I can consider them inside the same process ID, OSPF 1. Okay, but each one of them may be in a different area. Maybe, no, this is my area. Maybe this is area 1, this is area 2, 3, 4, but I'm sorry, the most important is something called area 0. Okay, when we come to the concept of areas, area 0 is something mandatory to start your OSPF network with. It's called the backbone area. And if you have any informations about the backbone, it's where everything else is connected to, because it's the item that connects or joins everything together. So area 0 or the backbone area in OSPF is first something mandatory. It must be there. You can make your entire network inside area 0, no problem. But once you start expanding your network or your regions and you want to isolate them and categorize them even better, okay, and need more areas, you must remember first that area 0 must be there. Okay, you must start with area 0 because only area 0 works, and the other areas that are connected to area 0 also works. The first thing, area 0 is mandatory, it must be there. The second thing is that whatever area that you wanted to operate correctly and be involved in your network, this other area must have at least one router of its routers that has a direct connectivity to one router of area 0 routers. Okay, in the final, I don't care how big this province is and how far it is from area 0, which is the backbone area. In the end, it must has one of its areas, maybe it's very close to the borders, it must be connected in a direct connection, a direct link to this one, to a router from area 0. Also for area 1, it must have a router that is connected to area 0. Area 4 also connected together. I don't care about a connection between area 3 and 4, a connection between area 1 and 2, or maybe a far connection between area 1 and area 4. In the end, all of them, all these 4 areas must have a direct connection back to area 0, just in order to operate correctly, to have a correct routing process, and to have its route installed in the database and in the routing table. Okay, so this is very important to have and to operate. This is only the concept of the area ID and the process IDs. Okay, in the professional exams, in the upcoming certificates or blueprints or exam materials that you will study, you will discover that there are types of areas. Okay, it's not just area 0 or area 5 and that's it. Each area might have a different type. Some complication will happen between each area and another. If some area is connected to some different type of area, what will happen between them? Who will be able to talk to the other? Who will listen? Who will not listen? Some complication will happen, but in case we have made any course for the new exams or for the higher level exams, of course we will talk about it. Okay, so this is about the types of areas that you will face in the upcoming or in the higher level certificates. This is something. The other thing that you will also see that this OSPF is called OSPF v2 because it supports IPv4, and there is something called OSPF v3 because it supports IPv6. In the past video, in the last video I have uploaded, we have talked about static route IPv6 or IPv6 static route because it was listed in the blueprints of the new CCNA, but OSPF v3 was also removed. It was mentioned in the last CCNA, in the previous CCNA, but in this CCNA it was removed. This is something. The other thing was in the previous CCNA is that the labs were to be in different areas, so I must configure multiple areas in my lab. In the new CCNA, it got more simpler by removing the need for areas in the labs, and the blueprint contained only mention and configure a single area OSPF. Okay, I know it's much simpler, but this is what Cisco asks, so this is what we will discuss and implement in the course. Okay, so again, we have talked all about these 7 points. Okay, after this we will talk about new things, which are some unique terms that you will see only in OSPF. Whenever 2 routers are configured for OSPF and now they are meant to start negotiating and talking to each other using OSPF routing protocol, all the types of messages that will be sent between 2 OSPF routers are called, you know, the family of OSPF I mentioned was link state family, so they will use a link state messages to discuss between them, and there are three types inside a single message. Okay, so all of them are called a link state advertisement or an LSA. An LSA is the unified message that will be sent between the OSPF routers for information updating, neighbor adjacency, route sending, more information about the router ID, about myself, about my routes, about my neighbors, and requesting from you to tell me also who are you, your router ID, your networks, your networks, I'm sorry, your neighbors, the installed routes in your routing table, etc. So all of these are negotiated and sent going forward and backward between routers using what's called the link state advertisement, or the LSA. Okay, the types of LSAs are, it's either a link state request where maybe router 1 is requesting some missing information from router 2, so please send me some missing information because I think that you are hiding something from me, or you have recently have new updates or new news but you haven't informed me about. So this is what I will send to him, and to it an LSR, a link state request, in case R2 replied me, and it should reply me, it will reply me with an update. It's a link state update, the reply for the request. Okay, after I receive the update, I must thank him and inform him that thank you for cooperating, and inform me back with the queries or with the missing information that I have requested from you. So I will third then send a link state acknowledgement, which is the reply for the update. So not a lot of details must be mentioned in the new CCNA about the link state, the LSAs. These are the brief things that I have mentioned about them. But also, like areas, there are types of areas. There are a lot of types of LSAs. I believe so far with OSPF v3 we have reached maybe 11 total type, or maybe 13 type of LSA. There are 13 type of LSA. Each one of them is specified for a single operation or a function. It will only be sent from a router to another router just in the case that I needed to inform him or request from this router about such specific thing. Okay, so we will know in the advanced professional, specialized professional, even expert technologies and certificates, 13 type of LSA, and each one of them its function, when will it be sent, in which cases and scenarios, and what to expect from them when they are sent or received. So in the higher level studies you will know types of areas and you will know types of LSAs. Okay, there are area IDs, maybe they were stub and total stub, not so stubby and totally not so stubby. There were 4 types of areas beside the normal area, which I have not applied anything for it. So 5 total types of areas and 13 type of LSAs, link state advertisement. This is the complication of OSPF. OSPF is very annoying when talking all about not practical side, about theoretical side. It takes maybe hours of talking. If I wanted to mention everything, maybe it will take really hours of talking without starting to implementing labs, just because talking and describing, comparing, and also the theoretical sides of OSPF, it's very big and complicated routing protocol. But being this big and resilient, it's the most resilient routing protocol, but is what makes it the last man standing. This is the last routing protocol left to you to know. So having a routing protocol mentioned in the CCNA, CCNP, and CCIE of all the certificates makes it that this is a very important router and very important protocol, and all the engineers must know it. This is the point of leaving only the OSPF as a dynamic routing protocol in the new CCNA. So this is enough talking for this video. I believe we have crossed 20 minutes. I will talk even further theoretical. Things that you must know about OSPF in the upcoming video. After that we will directly start with the implementation and the labs. Maybe we'll take 1 up to 3 labs like static routes. Okay, thank you for watching.